We've been working with implicit differentiation, and I wanted just to review what we did yesterday and then come in and do one more an example and then move into derivatives of logs. So recall implicit differentiation we used when we had an equation in implicit form, not explicit, where we had variables x and y on both sides of the equation or just on one side, where it could also be difficult to or impossible to solve for y and get it in terms of x. So this is where implicit differentiation came into play and is really helpful. So recall, in order to use implicit differentiation, you're going to differentiate both sides of the equation with respect to x. When we see the variable y, we think of that as y is f of x, is the function of x. So treating y as a differentiable function of x. So whenever we took the derivative with y, we would treat it just like we took the derivative of x, but we tacked on that dy dx. Once we've differentiated both sides, then we're going to collect the terms with just dy dx on one side of the equation and get all the other terms to the other side, and we would solve for dy dx. Okay, so that was just a review of what we covered yesterday, and we did some problems. So let's look at one other problem that we didn't look at that type, and you might see on your homework. Okay, so this example says verify that the given point is on the curve and find the lines that are tangent and normal to the curve at that given point. And so we're given the equation x squared plus y squared equals 9. And we want to look at this at the point -1, 3. So first it says, let's verify that that's actually a point. So our x value is -1 and our y value is 3. So let's go back in there and plug that in. So if I plug in x, which is -1, and it tells me to square that, times 3 squared, is this really equal to 9? Well, -1 squared is 1, and 3 squared is 9, and 1 times 9 is equal to 9. Okay, so we verified that that is a point on this equation. So now we want to find, let's first look at the tangent line. So to find the tangent line, we need the slope at that point. And we know to find the slope, we're going to look at the derivative. So we want to find the derivative of x squared plus y squared equals 9. So we want to look at taking the derivative of both sides of our equation, and we can write that as d dx of x squared times y squared equals the derivative d dx of the constant 9. Well, notice on the left-hand side, that's a product, x squared times y squared. And so we're going to need to use the product rule. And so the product rule says we're going to take the derivative d dx of the first function, x squared, times the second function, y squared, plus the first function, x squared, times the derivative, d dx, of the second function, y squared, which is equal to, well, the derivative of a constant is always 0. So let's go through and take the derivatives. So the derivative of x squared, that is just 2x times this y squared, plus the derivative, x squared, now times the derivative of y squared. Well, that is just 2y, but y is a function of x, so think of it as taking the derivative of the inside. So we would tack on the dy dx here. This is all equal to 0. So we want to get dy dx by itself. So let's subtract 2xy squared on both sides. So if we subtract 2xy squared on both sides, we're going to be left with, I'm going to just pull the 2 out front, 2x squared y dy dx is equal to, and I subtracted the 2xy squared on both sides. So let's get dy dx by itself. Let's divide both sides by this 2x squared y. So if we divide both sides by the 2x squared y, we get dy dx is equal to negative 2xy squared all over 2x squared y. So I want to use my rules of exponents to simplify this. And also I see I have a 2 in the numerator and denominator. So I find that my derivative, dy dx, is equal to, well, I have an x divided by an x squared. First of all, I have a negative. X divided by x squared, that's going to leave me an x in the denominator. And a y squared divided by y leaves me with a y in the numerator. So that's the derivative function. But I want the derivative at that particular point, negative 1, 3. And so we want to find out what the slope is there. So the slope at negative 1, 3, we're going to just plug in our x value of negative 1 and our y value 3 into this function. So we get dy dx is equal to negative a y value, which is 3, all over our x value, which is negative 1. So this would equal 3. So our slope of the tangent line is 3. So we have the slope and we actually have a point. And so to find the, let me just make sure what they wanted. They wanted the equation of the line. So yeah, so I'm going the right way. I wasn't sure if they just wanted the slope or we had to go further. So we have the slope and we have our point. And so we can use y equals mx plus b, plug in what we know. Our y value is 3 is equal to our slope, which is 3, all times our x value, which is negative 1. So let's figure out what b has to be, plus b. So if 3 equals negative 3 plus b, so if I add 3 on both sides, my b value is 3. So with that and a slope of 3, my equation of the tangent line is y equals my slope 3 times x plus, and I made a mistake, right? If I add 3 to both sides, 3 plus 3 is 6. So what my equation of the tangent line is y equals 3x plus 6. You just noticed. So in the next question, we wanted to find the equation of the normal line. Basically, the normal to the curve, this is a perpendicular line to the tangent line. And so we just need to remember what we know about slopes of two lines, that the lines are perpendicular. So I know that if my slope here was 3, I don't know if you guys remember the capital T, upside down capital T meant perpendicular in geometry. So the perpendicular slope, in my case, it's the negative opposite sign and the reciprocal. So taking the reciprocal of 3, I get 1/3. So it would be negative 1/3. So this is my slope of the normal line. Again, we still have that point. We still have the point negative 1, 3. And so knowing a slope and a point, we can find out what the equation of that line is. So again, we can go back in and plug in. So y equals mx plus b, what we know, solve for b, and then rewrite our equation with the slope in b, our y-intercept. So going back and plugging in, we get 3 is equal to my slope, which is -1/3, times x, which is -1 plus b. So we get 3 is equal to +1/3 plus b. So I'm going to subtract 1/3 on both sides. I noticed that I have a whole number and a fraction. So if I think of this as a common denominator, getting a common denominator, that 3 is the same thing as 9/3. So subtracting 1/3 from 9/3, I'm going to get 8/3 is equal to b. So that and my slope, we get y is equal to our slope -1/3 times x plus b, which was 8/3. And this was the equation of the normal line.